Trigonometric functions of any angle. Recall, coterminal angles are angles that have same initial and terminal sides. So in order for us to get coterminal angles, we added 360 or we subtracted 360 from the original angle. Here it says find one positive and one negative coterminal of 115 degrees. So what we can do here is we can do 115 plus 360 to get a positive one, and then we can do 115 subtract 360 to get a negative one. So the one which is negative will be negative 245 to negative 245 degrees, and for the positive one, when we add these two, we will get 475 degrees, and these both are coterminal angles to each other. Now for the second part, it says calculate sine of each of the three angles. So sine of 115, sine of 475 degrees, and sine of negative 245 degrees. So let's check what happens there. So let's calculate values of, let's say we calculate values of sine 115 degrees. See what we get. So in our case, sine of 115 degrees, if you were to round that to 3 decimal place, the number we get here is 0.906. Now let's try to find value of sine 475 degrees. So if you find value of sine 475 degrees, again the value we will get here is 0.906. And lastly, if we found value of sine negative 245 degrees, if we found value of negative 245 degrees, the value we get is again 0.906. Similarly, let's try to find values of cos of those three angles and tan of those three angles. So let's look at cos. So let's see what we get for cos of 115 degrees. Cos 115 degree is negative 4.23. Negative 0.423, negative 0.423, and then let's try to find value of cos 475 degrees, and that also we get negative 0.423, and lastly let's try to find value of cos negative 245 degrees, and the value we get is negative 0.423. so same values, okay, for all three. And lastly, if you were to do same thing for the tan, let's try to do same thing for tan of those. Tan 115 degrees is negative 2.145, negative 2.145. Let's try to do same thing for tan of 475 degrees. We get negative 2.145, and lastly, if we did same thing for this one, we do get negative 2.145. So what we can say about these results is, no matter what coterminal angle we have, the value will be same. The value for sine theta or cos theta or tan theta will be same. Coterminal angles, we can say. Okay. Now the fact is that the trigonometric functions of coterminal angles are equal, as we talked about. Therefore, it is sufficient to be able to calculate the trigonometric functions of any angle between 0 degrees to 360 degrees, one complete circle. After that, it's just keep adding 360 to that same angle and we'll still get same trigonometric ratio. Now let's define something called reference angle. Reference angle is basically the acute angle, meaning between 0 to 90 degrees, formed by terminal side of an angle with the x-axis. Okay, so always with x-axis, angle between 0 to 90 degrees, which is acute angle, we will call it alpha, which will be reference angle. Reference angle alpha is angle between x-axis and terminal side such that the angle is between 0 to 90 degrees only. So let's check. So we are asked here to draw and label the reference angle for each of the following. So if your angle in standard position, which we call theta, is in the first quadrant, then in the first quadrant theta and alpha both are same. So this is also alpha. Now let's say if it is in the second quadrant. According to the definition of reference angle, the angle has to be acute, meaning between 0 to 90 degrees, and it has to be terminal side with x-axis. So in this case, the alpha will be from here to here. Okay, so theta is always in standard position from positive x-axis in counterclockwise direction, while alpha is positive any x-axis with terminal side such that alpha is between 0 to 90 degrees. So if it's in the third quadrant, theta in standard position goes from here to here to here to here, but alpha will be just this much angle with negative x-axis and here. Okay, and in the fourth quadrant, theta is starting from here, it goes to the second quadrant, third quadrant and fourth quadrant. All of this is theta, like this entire angle is theta, while alpha is with x-axis and terminal side between 0 to 90 degrees, so it's only this much. So in the first quadrant, this is my alpha and theta both are same. In the second quadrant, alpha is right here. In the third quadrant, alpha is here, and fourth quadrant, alpha is here. Now let's see how alpha and theta are related. If we are in the first quadrant, if you notice, theta and alpha both are exactly same. So I can claim theta equals alpha. If we are in the second quadrant, we know this straight line makes 180 degrees. So if this much is theta and this much is the remaining from 180, the relation between theta and alpha in the second quadrant will be theta equals 180 subtract alpha. 180 minus alpha. Okay. So this is 0, 90, 180. We do not connect it with 90. We always connect it with x-axis. So either 0 or 180 or 360. So in this quadrant here now, we know this entire angle is theta, while this is alpha. So it's theta is basically little bit more than 180, and that more is alpha. So the relation here in the third quadrant between theta and alpha will be like this. Theta equals 180 plus alpha. And in the last quadrant, quadrant 4, theta is all the way from here to here to here, and alpha is this. We know one complete circle is 360 degrees. So theta here will be then 360 minus alpha. It is very important to know this in order for us to solve for any triangle at any angle in any quadrant. So in the first quadrant, theta and alpha are same. Second quadrant, 180 minus alpha. Third quadrant, theta equals 180 plus alpha. And in the fourth quadrant, theta is 360 subtract alpha. Since the reference angle is an acute angle, the values of all 6 trigonometric functions will be positive. So whenever we do something alpha, it will always turn out to be positive. So we can now use CAST rule, C-A-S-T, all positive in the first quadrant, sine positive in the second quadrant, tan positive in the third quadrant, and cos positive in the fourth quadrant. And we follow these steps. We calculate the angle for reference angle first. So first step will be to find alpha. How do we find alpha? We will do inverse of a trigonometric function with absolute value. Why absolute? Because we want to make sure that our reference angle is in the first quadrant between 0 to 90 degrees only. Okay, our alpha has to be between 0 to 90 degrees only. It doesn't have to be in the first quadrant. It's just, it has to be between 0 to 90 degrees. It has to be a positive number only. Okay. Now, once we get alpha, then as we saw, in order for us to find theta, we can use any of these four. We can say theta equals alpha, theta equals 180 minus alpha, theta equals 180 plus alpha in the third quadrant, and theta equals 360 minus alpha in the fourth quadrant. Okay. Once we have all this, let's look at how do we solve problem and what kind of problems we expect to solve from this information. It says find theta for 0 degrees to 360 degrees, so theta is between 0 to 360 degrees, given that tan theta equals negative 2.86, and we want to round our answer to 2 decimal places. So we follow 3 steps. The first step we decide is in which quadrant this happens. So we saw earlier how to decide. We have tan theta and we have negative tan theta. So negative tan theta, so let's look at here. So we are given tan theta to be negative, and we know tan will be negative in which quadrants? Tan will be negative in quadrant 2 and quadrant 4, because tan is positive in quadrants 1 and 3, it's positive. So the angle will fall between quadrants between or in quadrant 2 or quadrant 4. Okay, that's where tan is negative, quadrant 2 or quadrant 4. Other two, it's positive. So my first step is to decide which quadrants, and that's using the cast rule. Now second step will be to find alpha. Because we are given tan theta equals negative 2.86, when we find reference angle, we have to remember we always use positive value here. If this was positive, it will stay positive. If it was negative, it will change to positive. And then alpha will be tan inverse of 2.86. So tan inverse 2.86 is roughly 70.73 degrees. So alpha is 70.73 degrees. Now once we have alpha, in the last step we find out theta. And how do we find theta? Theta will be depending on which quadrants, we call it theta 1 and theta 2 for example. In quadrant 2, theta will be, as we saw earlier, in quadrant 2 I can call it theta 2 or whatever names you want to give it. Theta in quadrant 2 will be 180 subtract alpha, and theta in quadrant 4 will be 360 subtract alpha. So in our case it will be theta 1 is just first angle. Doesn't matter if you want to call it theta 2 and theta 4 or theta 1 and theta 2. So the first angle we will get is 180 subtract 70.73 degrees, which then will give us 109.27 degrees. Will be 109.27 degrees. And for the next one then, we have 360 subtract 70.73. We will have 360 subtract 70.73. The angle we get is 289.27 degrees. So we get two angles which satisfies this condition. One is 109.27 and another one is 289.27 degrees.